In this video, we're going to investigate the second derivative. Here I have the function set up as x cubed minus x. Again, you're welcome to change this function here. Everything should work if you change things around. We can look at the derivative of this function either using the power rule or others we'll see later. By simply graphing it, Desmos can do this quite easily. Asking for f prime of x. We're then going to look at the idea of see what happens when I look at the f prime x regions. If you look at the situation here, what you see is that when the blue graph is positive, I have shaded the region purple. And when the blue graph is negative, I have shaded the region orange. So if I turn off, if I look at this, again, the relationship between the shaded regions and the blue graph is pretty clear. In the purple region, the blue graph is above the x-axis. In the orange region, the blue graph is below the x-axis. But what's the difference? What's the relationship between the shading and the red graph? Well, for the red graph in the purple region, the red graph is increasing, whereas in the orange region, the red graph is decreasing. This is information we saw before. So now let's look at the second derivative. Again, simply we could look at this being the derivative of the blue graph. So we take the derivative sketch here, first plotting our zeros, and looking at different situations. Then we look at this, it has a single critical point, so a single zero of that graph. To get this situation here, turn off the derivative for a second. And again, I'll look at the regions of the situation. So the relationship between the colors now, this is where the second derivative is negative, this is where the second derivative is positive. So again, in this graph, when you're in the purple region, the graph is above the axis. When you're in the orange region, it's below the axis. What's it look like for the derivative? Well, again, when we're in the orange region, the blue graph is now decreasing, as the second derivative is the derivative of this graph. So for this graph, this is where the derivative of this graph is negative. So we have a decreasing function. This is where the derivative of this function is positive. So we have a increasing function. What's the relation between the second derivative and the original function? Well, in the orange region, the function is both increasing and decreasing. In the purple region, the graph is both decreasing and increasing. So the second derivative does not tell us anything about increasing or decreasing. What it does tell us something about the concavity. You'll notice in the negative region, or in the orange region, the red graph is concave down. And the positive region, or the purple region, the red graph is concave up. So the f prime sign tells us whether the graph of the original function is concave down, if the second derivative is negative, or concave up, second derivative is positive. Remember that the sign tells you that something different, about the derivative. If the second derivative is negative, the derivative is decreasing. If the second derivative is positive, the derivative is increasing. This is the relationship between the second derivative, the first derivative, and the original function.